Okay. I think we're here. We're coming in. Yeah, okay. Looking good. Hi. Welcome, welcome, welcome. Okay, so here we are. We're back. I'm back. I'm Agent Ultra. I'm here to hack on this cool little project we've been working on. It's like a roguelike kind of game called... I'm calling it LambdaTrek. It's Star Trek inspired from an old series. Like this game design goes way back to like the 70s and 80s. And it's had many variants and clones over the years, like Star Trek, Super Trek, and the like. And we're building one in Haskell because we like to learn about functional programming. We like learning about programming in Haskell on this channel. And, I mean, among other things, but generally mostly that. Because it's not just for academics. I'm not an academic. It's not just for researchers. I'm not a researcher. I've never been a researcher. In my whole life, I just like making computer programs and stuff to do things and have fun. So, if this is your first time tuning in, you haven't seen the stream before, I'll just give you a quick demonstration and overview of the game so far. I use the build tool stack, pretty common little tool, handy dandy, comes with a lot of nice little features like being able to run a test runner real fast, only bytecode compile your stuff while you're in development, whatever, file watcher, and all that kind of stuff. Anyways, stack. LambdaTrek. DVD. LMBDA. Yeah. Okay. So this is what we have implemented so far. We got a couple of commands like move. Right, we can move over next here. That S is our ship. Okay. This little dash here, that's an enemy ship. Our goal in the game is to destroy the fleet of enemy ships in the quadrant before we run out of energy and before we run out of turns. If we run out of turns or we run out of energy, it's game over. We got the phasers command implemented so that you can like automatically fire on enemies around you within a certain range. You give it an amount of energy to use, and it shoots them. Phasers 430. There we go. So then we implemented destroyed ships. We got that. So there's some debris there now. We can recharge our ship when we're next to a space station, which we are, with the dock command. And we replenish supplies. We also have this nice handy dandy little dialogue system that kind of tells you what's going on. This little star down here, that's a star. So we can't move into the star. We can move next to it and that sort of thing. Okay. So the thing we were working on last week was implementing some like minor AI, enemy AI. Like it's not like super complicated AI for a game like this. It's very turn-based, and there's not a whole lot of decisions for the enemy to make. However, they're going to have a couple of state transitions and an opportunity to fire back on us after we take our turn. So very roguelike there, where we're going to take a turn, then the enemies take a turn, then we take a turn, the enemies take a turn, that kind of thing. And yeah, so let's get cracking on that. BT dubs, if you have any questions or you're like, you don't normally program in Haskell, or you do, or whatever, and you have any questions, just jump in and chat. Let me know what's up. Also, whatever. You can talk about anything. Okay, so update simulation. This is like where the entry point for our main loop, right? So we handle a command, we update the simulation. Command comes in there, we get process it. I think the mistake I made last week, well, not mistake really, but like we conflated handling enemies with also their state transitions. Right, so the enemy just open up my test code here. I think we implemented state transitions for them, if I'm not mistaken. And now what we want is for the enemies to shoot back at us. But all they're doing is changing state right now. Right. So I run our test runner. Oh, wait. I have that code stashed. Right, so let's run that and get our test runner going. Fast, that turns on just byte compilation, not full, like optimized native machine code compilation, which is a bit slower, but not that much slower, but a bit slower. And then the file launcher, there we go. And this should fail. We should have some errors in here. Doobie-doo-doo. There we go. Yeah, one failure here. So we expected something to happen with combat there. Right, it should damage the player ship, right? It's not damaging the player ship because handle enemies is only doing the state transition and then stopping. I think that's basically what's going on there. Let's go over here, right? We get all of our enemies out of the state, current state, and then for each enemies we call handle enemy. What does handle enemy do? Well, it gets the enemy state and handles the enemy patrolling or handles the enemy fighting. What does handle patrolling do? That's the default state for our enemies. It gets the player ship when it's in range. We zoom in the enemy sector, we update the enemy, we change it to fighting. That's it. That's fine, right? That's good. That's what we want to have happen. But we also want them to fire on the player ship. So we could just continue here and add the combat code to this thing. But what I think we should... the reason why I said I think we convoluted the two things together is that I think it's kind of nice that we have the separation of the state transition from performing the action that we're supposed to do in that state as the enemy, right? So this is like really our state transition function. So I think a quick little rename ought to fix the confusion here, and we can update our test to just test for the state transition, and then we can move on to the combat stuff. So let's clean that up. Handle enemies. So I'm going to call this we're going to rename it from handle enemies to update enemy states. And we'll change handle enemy to maybe a little bit more selective with this one. Handle enemy state, or update enemy state, I should say. Enemy state comme ça, just like that. Let's change that to update. Okay. So that's good there. Hopefully, I think that'll probably compile, although the tests will still fail. Okay, and this, I think this makes a little bit more sense now. Okay, so that's good. Let's update our tests. So when in the patrolling state, it should do nothing when the player ship is out of range. That's true. And I think that one's still passing. The one that's failing is that it should change to fighting when the player ship is in range. Well, that one's right. It's this one up here that I think that's failing. Yeah, it's update simulation. Okay, so when the player ship is in range of an enemy in fighting state, it should damage the player's ship. Okay, so I think the setup for this looks okay. Let's see. We have game state ship at this position. The command is to move into 7-3, which is in our test setup state close to the enemy. And then we calculate the next state by updating the simulation. And then we know there's only one enemy in the array of the sector. And we'll pull that enemy out. Get the initial state ship and the next state ship. The enemy state should be fighting. Well, that... Yeah, okay. And our hull... The next state ship hull should satisfy this function. That's less than... Its value is less than or equal to... Less than the initial state's ship's hull. Yeah, okay. So actually, the test is fine. We only have to actually implement the code to do that now. Okay, ignoring this, that our tests actually don't cover this part. So I'm going to temporarily disable this one, so that our test suite pass. We can commit what we have right now, and then we can go implement that test, the code to make that test pass in a separate commit. Okay. Okay, so add enemy state transition. We can go from patrolling to fighting. Okay, we'll implement the other state transition from fighting back to patrolling again. I think that will be fine. And okay, so let's enable this test again. Let's go back to simulation, and we're gonna have to add an action now for handle enemies, or reintroduce handle enemies. Okay. So maybe after all this enemy state transition stuff, handle enemies. It's a state function of game state returning nothing. It's going to be very, very similar to update enemy states. Except we're going to handle enemy, just like we had before. Right, and the type is int. That's the index of the enemy in the sectors array. State. Game state unit. Okay, so let's go ahead here. We'll get the let's get the, what do we need? Enemy data. We can case match on the enemy's state. Oh, wait, no, case, not lambda case, case on enemy state of patrolling. Gotta do something, and fighting, we gotta do something. That looks good. Cool. I'll handle enemy patrolling. Handle enemy fighting. The patrolling case will just do nothing for now, until we know what we want to do. There, we just want to make fighting work at the moment. Handle enemy fighting. Okay, so handling enemy fighting. What does our test say we need to do? What did we specify? Should know I wrote it, but it was a week ago. Let's just double check. It just has to be something less than the initial ship. So we just have to damage the player's ship. Hull. So we can just do a fixed number for now, and that would satisfy that test. That specification, I should say. Okay, so let's pull out parts of our data that we need. Do we need that right now? So we know we're in the fighting state. No, we're gonna ignore this for now. Okay, we're going to zoom in on the player ship. And we're going to change its hull. We're going to set the hull to full hull -1. Sure, ship.hull. Oh yeah, this ignores the arguments. We just have to be explicit about that. And cool, so that satisfies our test, our spec there. So we've implemented ship damage. So if we run the game now, we should move next to that ship and take, a little damage. However, we're not going to see that because we're not displaying the hull amount in the UI, so we should probably do that next. So in this change, we add handle enemy action. The enemy will fire back on the enemy turn and damage the player ship's hull by a fixed amount. Okay, we need to display the hull in the UI so we know that it's we can just see that it's working in the game. That would be nice. So let's go update the UI. So if you're just tuning in, and this is your first time checking out this project, we're using a terminal UI, terminal-based UI, and that's provided by this wonderful library in Haskell called Brick. It's a very declarative kind of UI library where you just specify what you want to display, and the library takes care of figuring out how to output all the terminal emulation codes to draw the thing on screen that you want. It's pretty nice. Okay, so our info panel we call it, is a widget which takes the form state. So we're going to get the game state out here, and we're going to add a new row for hull. Game state ship ship.hull. Simple as that. Looks good. Okay, so that should work. Now if we move next to that enemy ship, you see our hull is decremented by 1 there because they fired on us. A little more, they fire on us again. There we go. 07. It's interesting. Oh, did I make it 2? I might have made it 2. Oh, we subtracted 1, so why is it removing 2? Actually, that's interesting. Okay, it removes 1 there. It removes 2 there. There's 2 there. Moves 2 there. Removes 1. And fires on us even more. We have implemented, like, what happens in negative hulls. That's interesting. And kind of unexpected. I don't know if I have a good explanation for why that's doing that. Hey, evac baby, what's going on? Nice to see you. Thanks for coming by and checking out the stream. We're just working on our little Star Trek inspired roguelike clone of an old game called Super Trek or Star Trek, a variant, so on and so forth. And yeah, just trying to figure out what kind of bug did I just introduce. So, feel free, of course, to drop in with any questions or suggestions or what have you, you know. Tell me about what's going on. Do you program in Haskell? Do you not program in Haskell? Do you do game dev? Do you not do game dev? Those sorts of things are all good. Oh, that would be super dope. Yeah. I could definitely use some work on that. I gotta get better at the Twitch game. The branding, super important. If you follow the link above, there's a Discord. There's a channel there for the stream as well, so pop in, we can chat about that anytime. let's see. Handle enemy fighting. So for some reason, it's subtracting more from the hull than I want, or I expect. And if I go to update simulation... Did I leave some code behind when we renamed things over to the update state, I wonder? No, it just changes it to fighting when in range. Ah, yes, we did. That's what's causing it right there. Okay, so the update enemy fighting state, we gotta remove that to just be pure unit. Yeah, thanks Evac baby for popping by and offering to help with that. Appreciate it. Okay, so now the game should work properly. So we move closer to 7-3, like close to the enemy. Okay, now it's taking off the hull for one. Okay, now if we go like 8-0 whatever, it's hitting us again. Good. Okay, and then we can like phasers and destroy that ship. Enemy's destroyed. We can dock with a space station, recharge our energy, and we can update the docking command so that it also fixes our hull, things like that. Cool. Yeah. Oh, this track. That was an eagle. That was a hawk sound. I like it. There's a pair of red-tailed hawks that nested near my place. And I sometimes like to work outside in the sun or in the shade. And every now and again, I'll like get a compile, it'll go green. And like just the timing's just right that little hawk's out hunting and that hawk screech comes out. And I'm just like, yes. So good. Okay. Handle enemy fighting. So that's good. We got that done. Let's see. What do we need to do now? We could come up with a better formula for the enemy damage. No, let's commit what we have so far. So let's stage that first. Flight transition code. Add hull to UI info panel. Okay, kill that stash. Boom. Let's see. I'm gonna rebase a bunch of this. Move. Right there, and squash. There. There. Okay. That looks a little better. Okay. So then, what do we need to do next? Let's move. I want to move. I kind of want to move the enemy like fighting code over to combat. But I also want to make it more interesting. Okay, because we have this thing called shields, right? Your PC was shut down earlier. Oh, that's too bad. I was just thanking you for stopping by and offering to help with custom graphics. So if you want to pop in the Discord channel and chat with me about that sometime, that'd be great. The link to the Discord server's up there. Or you can reach out to me on the socials. I'm on the Mastodon, the Fediverse, Agent Ultra. I type stop PL. Okie dokie. Sure. Yeah, totally could do that. Okay, so let's see. All right, now we only have one enemy type. Yeah, so the link to our Discord server should be displayed right above my head there. It's at declarative.tv. There's a link right to the Discord server on that site. Okay, so yeah, I kind of want to make enemies have... It'd be nice if they have different... They hit you with different amounts. Maybe, or maybe we should just stick with like a fixed one. I'm not sure what kind of game. Like what does Super Trek do? Maybe we should look for inspiration there. These are all the commands. Yeah, they had, so like the original game had different levels and difficulty. Yeah, I think depending on the enemy level, they would do kind of the same thing back. Star Trek game, enemy damage. Ah. Yeah, I'll leave it for now. That's good enough. We got something. Okay. You know what we can do right now? We can implement the state transition back to patrolling from fighting. So if the player moves away, out of range, let's implement that. Okay, so we go to our state of transition code here. Let's add a test for it in our spec under enemy AI. Start a new context. When in the fighting state, it should transition to patrolling when the player moves out of range. Okay, so let's set up our initial state for this test. Something like this. Except the ship will already be in range at 7-3. And we will be, say, moving to 14-14, which is probably about the bottom right corner of a sector. Okay, and then we calculate the next state, just as before. Then we should see that the well, the hull is still going to be damaged, right? Because the enemy turn comes after we process the player command. Well, actually, no, we can still check the state of that. So, anyways, we just want to check the state transition here. So I'm getting a little ahead of myself here. Let's pull up the enemy. And then we can check that the enemy's in the right state. Should be patrolling. Alright, we can focus on this context for now. Oh, of course, the enemy started off in the patrolling state to transition to the fighting state. So, no, let's start the ship at 14-14. We move into range, so it transitions to fighting. Okay, and then there should be fighting. And then we get another state. Where we take the next state, but the command is to move out to 14-14 again. And then the enemy, we get the enemy back out again. We will call it enemy prime. I'll get it from final state. And this enemy is the enemy prime's final state. Should be patrolling. And this one ought to fail if it compiles. All right, and that should be our, I think that'll be our test there, yeah. So there it's failing. We want it to go back to patrolling, but it stayed in fighting, which makes sense. I think we can clean up the test code a little bit to make it a little nicer, but that's good enough for now. Let's just make it let's make it pass. Okay, so how do we tell that the state transition should happen? Well, if we're in the fighting state and the player ship's no longer in range, right? When we handle the state transition, we know that the player ship has already been updated by the command, the player's input, right? So we can check the state of that ship and update our state accordingly. So I'm going to pull out this. I'm going to ignore. No, I'm going to pull out the index. I'm going to need the index, I think. And enemy. Okay. We'll get the player ship. Game state ship. And we can probably just pull out the ship parts. Ooh, no, we have that distance function actually. Maybe we just pull the ship. Yeah, let's see. In range. Yeah, we wrote this. This will be nice. We can use in range again. Do the enemy ships have range? I can't remember if I put that in. Check that. LambdaTrek. Simulation. Enemy. They have hit points, they have shield value, they have states, position. They don't have a range yet, so we can make up something for now. Hard code it. Which I think is what we do for the state transition into range 3, looks like. Yeah, okay. So, unless in range enemy ship 3, then we can change our state to patrolling. So we do this by zooming in on the game state sector. And we change enemy ships to be this formula here. Such that the enemy state is going to be patrolling. And of course, it's not enemies, it's enemies. Enemies, enemies. Not enemas. And that should be a squiggly boop, not a skizzity boop. Was that shadowing something? It is. So we're going to call that enemy X like we do above. Try and be consistent, if nothing else. Okay. I think that'll pass now. It does. Cool. Oh, that's what we should add. When the enemy hits us, we should get a report. We should add some dialogue. Okay, we'll do that next. State transition from fighting to patrolling. From fighting Enemy enters the patrolling state when the player's ship is no longer in range. Okay, let's have that handy dandy dialogue when the ship is damaged. There might be some other things we need to test here, but so we can say dialogue. No, combat. Failed to compile. Right, we can't do that in there. It's not the right monad. Okay. Okay, so how do we do this? Should probably check that the ship is in range. And if we damage the hull, then give the hull report. I'm going to create something called a damage report. Direct hit. And maybe an amount. We'll drive our usual classes. You can show. Sure, make it a new type for now. Okay, and so when we handle the enemy fighting, let's see, let's check that the ship, I mean, we can assume the ship is in range because we can only get into the fighting state if it's in range. And if we move out, it'll change states back to patrolling. We can just still check in range. Ignore that. We need the ship. Then do well, at this point we know that we're going to hit them. So we could do the dialogue here. On that. Maybe we don't need this. All right. Let's do nothing for now. We need to give a range amount. Get the ship. it's not say dialogue, is it? What is say dialogue? What's the problem? Crewmate text. Oh, but it thinks I applied it to 4. Ah, well, because we don't have a do there. There we go. That's better. And then that should be fine. Let's take the focus off. Okay, run our game again. Okay, there we go. Sweet. And if we do phases here, we destroy it before it hits us. We shouldn't get a hit. But it's still saying direct hit. We have to check if we're still alive. So we can actually do that by filtering the enemies before handing them off to handle enemy. Yeah, let's commit that for now, because that does work, and then we'll fix the other thing. Yeah? Good. Add combat dialogue. Direct hits. If ship hull is damaged. And tell the player so. Or remind the player. Okay, and then we need to fix that bug. Or a bit of code that we haven't really implemented yet. Kind of a bug. Shouldn't leave it in. It's not right. Okay, so in handle enemy fighting, or update enemies, we should only allow enemies to update that are still alive. Same for state transitions as well. So we add that function to filter. That needs the dollar sign there. That's the apply. Okay. So that filter should be like is alive, basically. We don't care about the index. We don't actually need the enemy to return anything. We're returning a boolean, so we can pull it apart there. We can just say, we can just check our, I think we have a flag for it, if I'm not mistaken. Oh, we have a function, is destroyed. So we just pull the enemy. We want not is destroyed. Or, put another way, is alive. And I think we can add that to that module. That would make fine. Is alive is a function of enemy to bool that is simply not is destroyed. Yeah, that's not going to quite work. We do need the... We do kind of need the... Right, is alive a little differently. Because it's going to take the index of the enemy here. Because we're taking the association lists. So, that's going to be the bool. Enemy dot is I think that one will work. Yeah, that'll compile. Okay, and we also need to do state transitions. So I'm going to basically do the same. I'm planning to do basically the same transformation we did here on handle enemies. I'm just going to add a little update to our spec just to make sure that this is working as intended. So when in the patrolling state, should change to fighting when the player's ship is in range. So it should do nothing when the player ship is out of range. Should do nothing if the enemy is destroyed. Okay, and how can we could do game state sector equals like the basic sector. The empty sectors such that the sector enemy ships is this array. Only the enemy health, the enemy energy. That's the third value is 0, so that is destroyed. Okay, I don't have that in scope. I have it in scope like this. Right. Yeah, okay. And No, let's make it so that the engine move is moving next to the enemy ship. Or in the enemy ship's range. And that should fail the test. Or not compile. No, fail the test. Okay, good. That's what I wanted. So it's doing the state transition to fighting because we haven't added that check-in. So let's go and do that. Handle enemy patrolling? Yeah. Okay, so let's go do that here for handle update enemy states. Yeah, here. Here. I wonder how many times I've typed that typo. Too many times, I tell you. Too many times. See, I did it again. Now, because I'm thinking about it, I'm probably going to do it more often, but hey. Now that test should pass. Okay, so that worked. Good, good, good. So let's commit that. When applied, this change will ensure only alive enemies can change state and interact. And let's see if we can clean this up a little bit. I think there's just a smidgen of things we could do here. So this pattern is just repeated twice. So I think we can make a handy-dandy little function for that. I mean, yeah, I guess. I don't think it would buy us a whole lot, to be honest, actually, now that I think about it, because we just... Like, I don't even know what I would call that, to be honest. Let's just type it out. Import qualified. Out of the way. fine. So the type error here is not right, obviously. Who is on array int of enemy to a list of int enemy. And this is alive. It's not quite that is alive. It's more like this, which we can shorten to is alive with the second, after second. Right, maybe we could call this, maybe it belongs more in sector. That would be alive enemies. And since this is sector, let's just pass in the sector. And we can take the sector enemy ships. We have that in whole module scope like that. Okay, so then we can get rid of this. We can replace it with live enemies. We can just get the sector. And then we don't need that. It's pretty alright. We can do the same here. Go to this, make that sector. Do that, this. And we can get alive enemies of the sector. Yeah, it's a little cleaner. Okay, that's good. Let's get that. This is a refactor change. We are adding live enemies to sector. I don't like the way that's worded, but I'm going to fix it. Okay, and let's see, what do we got? We're pretty good on time. Let's keep going. Let's see here. So the other thing we can do is this magic number here. 3. That's like the enemy range. We'll probably add that to the enemy. So, we probably have a bunch of build errors because we use this constructor in a lot of places. Oh, okay, so far only 1. 2. Not bad. Okay. Sector. But I added enemy range before the state, so we're gonna make that 3. That's the magic number we've been using so far. Let's add it there. And then our next compiler will be in the spec, I think it was. Yes. A bunch of places in spec. Spec. Yeah. Alright. Just go there. Okay, and it's gonna be range 3 there, there. I feel like I'm just typing in a magic number here in all these different places in the constructor, and then we should make this just a constant. Yeah, you know what? What's it gonna do? Get rid of all of it. Yeah, no, don't like it. Let's go to the enemy module, just make it a constant. Enemy range. And then in simulation, we could just use that value. There we go. Anywhere else I had 3, yeah, one more place there. Boom. Add enemy range constant. That's nice. Okay. Let's go back to simulation. Okay. Okay, so that's pretty good. Keep it clean. Keep it good. Let's look at our commit factor. Yeah, I think all of these can be rebased into one. Reword it. Enemy firing, enemy combat. When the player ship is in range. There we go, that's pretty good. Okay. So let's play around with the game a little bit. We haven't seen it in a bit. Make sure it feels good. Feels good. Can't move directly in there. Everything's as expected. So we move in range of the ship. They fire on us after we complete the move. If we move away... Okay, we don't take a direct hit, right, because we're not in range anymore. But if we move back into range again, we should take another hit. Okay. And then we can fire our phasers. Destroying that enemy ship. And if we move, like, around in your ship, they're no longer firing at us, because it's destroyed. So now we can dock and recharge our energy and take up some turns. So I think the next thing we should do is update docking so that it repairs our hull. Let's go do that. So we're next to the station. We should zoom in on the game state ship. Set the ship energy to 100 and ship.hull back to 10. Right. And that will work. Ooh, we should probably also remove the focus on the test. This repair hull and docking. Okay, now repairing and docking at a station to recharge all of this energy and repairing your hull and loading in new torpedoes should have a higher cost in terms of turns used in order to perform that, right? To balance things out a little bit in the game. So when we update the simulation, we get the command result performed. What do? We do the turn cost command. So maybe we should update the turn cost for this command. So we go into command. I just feel like it's not enough. Docking 5. Yeah, let's make it like a little higher than that. It's like 15. I don't know. Something pretty high. cool. Yeah. So the other thing we need to implement are shields for the player. Alright, so there's like direct hits on the hull. That's when the shields are all down. The enemy has worn you down. And then that's when they can hit your hull. But otherwise, if they try and hit you with their weapons, they hit your shield. And your shield should strip away the damage from your energy instead of your hull. So let's go implement that. Stop. Yeah, let's start with the ship. And we should have like a shield state. Let's add that up here maybe. Shields up, shields down, and we can have a third state, which is shields offline in the game, but I'll save that for later. Alright, so shields offline would be like if we want to simulate being able to like damage inside the ship when a direct hit occurs, affecting ship systems like the shield state. Right, that would be kind of neat. Or if you're low on energy. Alright, we have to update our tests because our tests will fail because we assume a certain amount. Let's pick for docking. Remaining turns. Yeah, 185 because we updated it. Okay. Let's add ship shields state. That's going to need an ord. Okay, and then we have a bunch of places where we need to add it. Shields. Let's start with shields down. What's in here? No. That's in simulation. Ah, yes. So we'll do... Yep. Shield states. I feel like this is a good candidate for using the explicit fields. It's getting a bit long and hairy. Also seems like a good candidate for using lenses better in this code. It looks like maybe this is older code, or I wasn't using it good. Maybe. It just looks a bit ugly. Yeah, I should probably look at change that. Okay. But that should be about the same. Yeah, so that looks a little better. And then what do we got? So this is all spec stuff again. I'm just gonna pop something like this. I'm gonna jump over to chip. And I'm gonna do so I'm gonna do a little Emacs macro here. Okay. We're gonna search for the next instance of chip. Jump to the end of the line. Base shield down like that. Go to the next line. No, I started the macro wrong. That's okay. Okay, I can't do it that way. Shield down. That's good. Yeah, okay, we're good. We're compiling again. Test passing. Hooray, everyone's happy. Okay, so we add that. Let's add it to the info panel so we can see it in the UI. I mean, the lazy way of doing it would be like this. With a comma. This would be the lazy way of doing it, just like showing the instance, but I think we should probably write a better function for that so it looks nicer in the UI. Of course. User experience important. Alright, so we don't want shields down. We should have like a text function that translates it to text for the UI. So let's go do that. Take shield state, go to the text. Shield up. Shields down. And then we need to add a lambda case. And data.text. Oh, we need overloaded strings, of course, blah, blah, blah. Alright, so then we are going to it would be nicer, I think, if I could have a function from ship to shield state text. But I'm going to do this for now. We're going to show the shield, because then we're going to have to do the shield state text. And then we're going to have to give game state, ship. Ships, shield state.
And what will happen then will be truly dramatic and spectacular. I don't see it as some kind of phase, a transformation of humanity. Rather, I see it as its end. It is possible that some humans will either be uploaded into machines, genetically modified or augmented with nanotechnology. But it will be an anecdotal event when compared to something as dramatic as the creation of an artificial intelligence.
So let's try that again.
Human beings are
Oh, the show instance with quotes around the text. We don't want that.
It's appropriate to call them human.
But we actually want text on pack.
Something else. Something new.
So we're gonna need to import that. No, we have it already. Cool. There we go. Sweet. So let's do the shield command. So we're gonna need to parse it for that. Where are we? Reflector shields. Yeah. Just shields. And shields up or down. Oh, okay. Yeah, it's a little bit more interesting than just that. However, we're just going to implement up and down for now. And it's supposed to cost you energy to raise the shields. So, cool. All right, so let's implement the parser first. Oh, and the commands. So we have... That looks all good, all good. Okay, let's commit this. Add shield states to ship. And let's go to commands. Shields, and we'll just take the shield state here as well. Import LambdaTrek. Simulation. Ship. Okay. All good. Although we have an error here. Where is... We gotta match this on turn cost. Shield stay... Shields. Just costs 1 in terms of turns. Argument. Cool. And that's the command added. Let's add the parser. That's in the parse module under commands. Parse shields. Either a command parse error or a command. First thing we have to do is match the string shields. Then we need skip spaces. And then we need either up or down. Let's see. Can we use alternative? We're using the built-in text up parser combinators library from base. Not the greatest, but if you know how parser combinators kind of work under the hood, it's usable. Choice. Okay, so we'd have to write a parser for up and a parser for down, and then we could use choice to combine those parsers together to get one of them. So I want to parse shield state. Either command parse error, or otherwise we get a shield state. No, parse shields up. We're gonna do it like this. And all this has to do is match the string up. UF. And then we return shields up. And we similarly parse shields down with read-p. And shield state, which isn't in scope yet, but I'll fix that in a second. Come here. And similarly, all we have to do is match the string down. UF and here right shields down. And then we can parse shield state. Command parse error. And this is going to be our choice of either parse shield up or parse shields down. And then parse shields can now have the shield state. And I'm going to remove actually the EOFs from this. And put that here. And right. Shields with shield state. Oops. And I messed around and moved a few letters around. Here's the problem here. Yeah, not in scope, so we'll bring in shield state into scope. That's from import LambdaTrek simulation ship. Ooh, So this area here is we expected to type shield state, but we got either instead. I think we can fix this up by removing the eithers around these. That. Oh, name shadowing. Fine, that's fun. That work? Cool. Now we're parsing again. We're compiling. We're good. Okay, cool. So then the final step is we have to add parse shields to parse command. Just going to start moving this now. The list is starting to get a little long. Pull it over to the left a little bit here. Parse shields. Okay, that's all we have to do to add a command, so I think we should be able to, like, run this now. Oh, not exactly. Ooh. We have a pattern match warning probably somewhere that this command is just helping me ignore. We can go find it. Turn off the test runner for a second. Oh, it's not showing it. Where is it? Simulation online 41. Handle command. There we go. Yes. Shields. Handle shields. So now we'll need to implement that. Yeah. After handle docking. That'll be a shield state and state, game state. A lot of state. State. Everywhere is state. Ain't that the truth? That's just programming, son. Okay. Okay, let's just ignore it for now. We'll just say dialogue. Handling shield. Oh, it needs command result, sorry, not units. So we need to say dialogue and pure performed. Okay, now we should be able to see it. What's up? Cool. Shields down. Cool. So now we just need it to flip state of the shields between the two values, but depending on the command. Okay, so let us get the ship's shield state. And we can match on that shield state. The shield state and the new state. And we have, what is it, shields down, and the new state is our shields up. Then we can zoom in on the game state ship, and we can set the shield state to be equal to shields up. And then we can return pure performed. Oh, I'm not using the right combinator here. Oh, shield state, that's right. So I have all my lenses scoped to the module, prefix of the module name. There we go. Let's see. Then we need prior shield is shields up. Now we have shields up. In this case, well, here actually we might also say dialogue. Combat. Raising shields. In this case, the shields are already up, so we might just let the player know that remind the player that's already the case. We might want to change the honorific in the game. Let the user can figure that out. I just noticed that for some reason. I was just skipping all of that this whole time. But anyway, so we say that, and then pure not performed. Or whatever that is. Denied. Okay, that's what we called it, denied. We have more cases. What do we got? Shields down in the prior state. And shields down. Now we can say something a little different. There. And pure denied. And then what do we have? We have shields up. But the new command is shields down. Now we can say dialogue from combat. Lowering shields. Maybe we could just change it all to captain. And then we can zoom in on the game state ship. And we can set the ship shield state to be shields down. And return pure performed. Done. Although, what's this warning I introduced? Shadow, another shadow line. Oh. Alright, that should be good. There we go. Sweet. So now we restart the game. Alright, we start with shields down. We go shields up. Changes to up. We are raising shields. And shields down. We go to down. If we're already in down, we go shields down. We should get shields are down. And if we go to shields up, we raise the shields, and if we do shields up again, shields are up. Okay, cool. Sweet. Now I think I'm going to commit that, and we're going to have to call it a night. We're out of time on the stream this week. Let's just review that quickly. Ship, parse command, add the command parser. That's good. Simulation, add the shield state, import, handler. Good. Yeah, this is pretty sick. There we go. Add handle shields. Transitions. Handles the shield. What do? We added the shield parser. The command parser, and added the command handler, and transitions the shield state. Boom. Okay. Let's just clean up this history a little bit. I'm gonna get rid of that whoops. Squash it up in there. Cool. All right, so that's the time I got for today. I hope you enjoyed and are having fun following along. All this code that I'm about to push up here is available on GitHub. I'm Agent Ultra. Welcome, if this is your first time tuning in. The code is on GitHub, also at Agent Ultra /LambdaTrek. So you can get that all there. That's the code for this whole project. If you're watching in a different time zone, you're not watching the stream, of course, you can check out my handy dandy YouTube channel where I am archiving my stream. Yeah, and I usually do these streams on Tuesday evenings at 10 after 8 in the Eastern time zone. But of course, you can also subscribe, like, follow, whatever it is. You'll get notifications when I go online, because sometimes I do these streams in between my usual schedule, and if you get notifications, you'll be able to tune in on that if you have a moment to come hang out and chill. What else? I'm also on the socials, of course, at types.pl/agentultra. You can follow me there, and so on and so forth. So, without ado, also go to that link above my head. There's a Discord server, and you can hang out there. Tell me about your projects. Give me feedback on this project. Whatever the case may be. Maybe you can ask a question you don't want to ask on stream. That's all good, too. It's always a party there. You'll also find other streamers who are doing programming in various other languages, like Haskell and others. Yeah, that's all I got for tonight. So let's go find someone to raid. Shall we? I think Strager's usually streaming around this time. Oh, nobody I follow is online right now. Okay. Well, I guess that's going to have to be that for tonight. Thanks for watching. We'll see you next week, hopefully. May all your monas be free, and may your types always check. Take care.